So now I think you should be able to figure out how to using all those functions here as we covered it in our previous lecture. So just don't mix y's with x. So the y here should be the Merck's return, and the x here should be the horizontal axis, which should be the S&P 500 index. So here, one thing I want to mention is this intercept and slope, the statistic for intercept and slope. Here, these are the user-defined function. In Excel, there's no function like intercept, slope, and R-square here, where you can just input the y's and x, and then simply Excel will just output the t-statistic and show you the significance of alpha and beta. So we actually need to write the user-defined function. Here, we are calling the user-defined function t-intercept, and then using Excel function index and Excel function liveness. So I introduced in the previous class, liveness is another way of doing regression. And index here is we're trying to let Excel know, like liveness can produce a lot of different estimates. Like a regression can produce the t-statistic, can produce the estimates, and can also produce the standard error. So which one do you want to use? So here, each of these numbers here will tell Excel which number that you're calling here. And then for here, index divided by the standard error. So this will call the standard error, and this is the estimate for intercept. So we're actually doing hypothesis testing here. So we're testing that whether the intercept is equals to 0. So our null hypothesis is that intercept is equal to 0. So we'll put intercept, the estimate of intercept minus 0 divided by the standard error. So now this will be the t-statistic. And then we'll compare the t-statistics in the t-distribution based on our degree of freedom, and we'll get a rough idea of whether this is significant or not. Now, usually, if t-statistic is greater than 2, then we're saying that this estimate is statistically significant. In this case, for beta 0.6, we have a t-statistic for beta that is equals to 4, which is really high. It is statistically significant. And for alpha here for Merck is 0.4. So the t-statistic is 0.4. So that means the alpha is insignificant. So the model here for estimating beta is pretty good. So we can say that beta almost explain all those variation in returns. It's a pretty good explanatory variable. And R-square here is pretty good as well, 22%. The model has a very good fit. So next one is to use regression add-in to obtain beta. So we want to use Excel to calculate the beta for us, but not using the slope function. I'm going to introduce another function in Excel called regression package. So we're going to go to data analysis. Now, if you don't have data analysis here, so go to files, options, add-in, Excel add-in, and check this analyst toolpack. Click OK. So go to data analysis, and you can do a lot of things here. You can do correlation, covariance, moving average, histogram. So we want to do regression. Click OK. Then we again see something like a, we just need to input something and then click something to output the things that we want. So the Y's here should be always the firm return. X here is the S&P 500. So now you can choose to output it in a new worksheet or output to a range here. And you can also check whether you want a confidence level, whether you want restrict constant to 0. Restrict constant to 0 means that you want to restrict this model so that it has intercept that is crossing the 0 here. So you don't want, you're restricting this regression model. So you just want to get rid of this intercept. And here, residuals means that we have a fitted line here. That means each of these dots can be represented by one dot in the line. Like given the same x, the predicted value on this line is at this level. And the distance between the predicted value and the actual value is called residual. And residual, so how many data points here will generate how many residuals? So you can check this box to see what are the values for residuals. And you can also check this plot for residual plots. So basically, it will produce a scatter plot for plotting all those residuals in just one graph. If you want to do some further analysis on, the quality of this regression and the characteristics of the data itself, you always want to check this residual plot. So I'm going to go ahead and click OK. So I'll have this here. Here, all of them is, is measured in time. This is just a default data format. Okay, so I'll just change the cell format here. Okay, so how to read this regression statistic? So we have R squared here, 0.22, and the R squared we get here using Excel function is exactly 0.22. And where's the alpha and where's the beta? So here for intercept, here this is the alpha, 0.0037, so 0.0037 here. And then for the beta, so 0.65, and it's 0.65 here. So here for the coefficients, these are the estimates for this is alpha, this is beta. And here it's we got the standard error. Now remember when I was introducing, where do we get this? How do we write the code for t-intercept? I'm saying that we're using hypothesis testing. So we're using coefficient divided by standard error to calculate the t-statistic. And this is exactly the t-statistic reported here. Same here for the beta. Okay, so this is the way of calculating t-statistic, relatively pretty simple. And now for p-value, it is based on t-statistics, and then it tells us directly, if the p-value, for example, we want to see at one level of 1% significant level, whether this estimates 0.065 is significant. We look at the p-value. Okay, so we compare this p-value to 1%. Obviously, this p-value is less than 1%. So we reject the hypothesis that this coefficient 0.65 is not significantly different from 0. So we reject the null hypothesis. So here, that means this estimate for beta here is statistically significant.